Phase 1, Melrose Arch. Consisting of a number of roadways and 5 buildings, it is touted by the developers as
a leading example of new urbanism, a lifestyle in 3 dimensions where home, work and recreation coexist.
Having dreamed up the concept and started to convert architects' drawings into reality, they had to keep the weather out. The engineers, Canty and Templar, were briefed to design, supply, install and warrant all materials and systems to satisfy the client requirements for the waterproofing and protection of the structures and buildings to best international standards, such that leakage of free water, dampness or condensation does not occur to an extent such as to cause damage to fabric or contents of buildings or the super basement areas. Stefanuti and Bresson completed the waterproofing team, a multidisciplined engineering company which has an ISO 9002 listing. The Decathane system, an elastomeric, fully reinforced polyurethane waterproofing membrane. It was selected by the appointed waterproofing design engineers from a final choice of 3 products because it was the only membrane available worldwide that complied with the overly stringent criteria set by the developers. The Decathane system starts with keen attention being paid to the substrate. Concrete surfaces completed by other trades are grit blasted in order to expose faults and defects, providing a suitable surface onto which the system can bond. High pressure cleaning equipment is used to remove any dust and other bond inhibiting material from the substrate surface. Defects in the substrate are repaired by means of a reprofiling layer of polymer modified cementitious mortar. All exposed horizontal surfaces are first screeded to form falls directing water towards the full bore drainage outlets. Sharp edges are rounded off to reduce the risk of damage to the membrane. Metal surfaces are abraded before priming. Gaps and joints left by other trades are filled with closed cell foam backing cord. Silicon mastic is used to shape a fillet around the metal protrusions and a polymer modified mortar is moulded to form a cove of 45 degrees between the upstands and the horizontal surfaces. The waterproofing engineers perform 70 quality assurance steps during the preparation and application of the membrane. One of these is for moisture content in the substrate, which is ideally 20% or below. Where deemed necessary, core samples are also taken. The substrate needs to be sufficiently strong to avoid failing under the varying loads placed on it. Although Decathane has a tested adhesion to bare concrete, a bonding primer or tie coat sealant are used in order to seal the concrete surface. Large areas are demarcated into predetermined squares to control the spread rate. Decathane EC is used for the second stage of the membrane, the embedment coat. Stefanuti and Bresson's waterproofing teams comprise of 3 members, all working in synchronized harmony. Here is a perfect demonstration of how user-friendly this liquid applied product is, given the proper training. Because Decathane is an all-purpose, fully bonded, monolithic waterproofing membrane, the practice of its application is identical in all situations. The final layers of decathane are sprayed on to complete the membrane, where possible at right angle. A great deal of emphasis was placed by the developers on the crack bridging ability of the membrane. Future shrinkage rates of up to 1.5 mm were to be catered for in all areas of concrete construction, and a total movement of 2 mm between the slabs and beams. The reinforced decathane system will detach itself from the substrate in the vicinity of those cracks, because its cohesive strength is sufficiently higher than its adhesive strength to the concrete. This allows the strain to be distributed over a greater area and eliminates the chance of localized failure of the membrane. Once laid, this maintenance-free system provides a completely waterproof structure for many years to come, and the guarantors can sleep peacefully. In the case of planter boxes and atriums, Decathane RR is used. This contains a root-resistant additive that inhibits penetration and is resistant to chemical fertilizer. The system is tested to the German standard DIN 2062 against lupin roots. The development boasts
a highly sophisticated communications network. The offices and other facilities will benefit from the incorporation of an intelligent backbone system. This will provide communication services throughout the precinct, as well as access to the latest data technology.
The roadways provide that backbone, accommodating and protecting this network. The Decathane system gives a double shield over the expansion joints. A joint is cut to a depth of 25 by 50 mm and profiled with a weak mortar. The clean joint is lined with despondent tape. The tape is then painted with a layer of Decathane, which is spread onto the primed concrete surface on either side. Heavy-duty nylon flexi-tape is moulded into the cavity, embedding the tape and forming the first stage of the expansion joint. When cured, the second shield is applied. Masking or despondent tape is used to bridge the created divide. This is then coated with Decathane, into which a further layer of flexi tape is embedded. The joint is then allowed to cure and tested by ponding and inspecting for leaks. No matter how many layers of Decathane are used in a particular application, its monolithic qualities ensure that it remains a fully bonded single sheet, making leak detection simple. The same chemical quality enables the membrane to cross-link itself between new and old layers, allowing waterproofing to be completed in sections. It also means that movement joints, protrusions and detail can be decathaned prior to larger areas. Stefanuti and Bresson made this replica of a typical joint to demonstrate the system's ability to cope with the dynamic movement required of it in the specifications laid down by the developers. Having witnessed that, they couldn't resist going further to see what would happen in the event of a major disturbance on the Richter scale. The second shield allows the system to stretch up to 3 times the width of the original joint and still offer a resilient waterproof structure. It was decided that if it came to this, the developer should leave the building and find another builder or develop elsewhere. An expansion joint created between a horizontal and a vertical surface is similar in concept to any other expansion joint detail. The only difference is that a half-round foam tube is placed on the first shield of heavy-duty flexi tape. Bond breaker tape is applied. Flexi tape is measured, cut and embedded. And the shape of the joint and the differential movement between the two elements are accommodated. The first stage of a vertical 90-degree expansion joint, waterproofing the recess and flowing on to cover the associated fissures, almost abutting a completed horizontal joint which separates the roadway from the building. These are protected by creating a void over which concrete is cast. Horizontal surfaces are protected by plastic boards interspersed with geotextile fabric to prevent debris entering the composite. After the membrane on the roadway has been completed, drainage for the vertical surfaces is required as well as protection for the waterproofing. This is supplied by means of a composite drainage board and a geotextile layer. A formed galvanized steel plate supported by lintels and then overlaid by concrete further protects the expansion joints. Waterproofed areas are then backfilled by Stefanuti and Bresson to a depth of 300 mm in order to protect their work before handing the waterproof site over to other trades. A termination detail, whether into concrete or brickwork, is identical. A groove 6 mm wide and 15 deep is cut into the surface. The membrane is then moulded into the termination point. The remaining space is filled with polyurethane mastic sealant. Some skillful dressmaking techniques required at full bore terminations. The two pieces of tailored mat are then embedded into the full bore, one on top of the other. This operation interlinks the glass fibre, ensuring a continuously reinforced system. Pull-off tests are performed by the engineers as part of the quality assurance program. This is particularly important, especially on the roofs, where wind loading is a critical factor. The UV-resistant Decethane SP has to be fully bonded to the substrate to enable it to resist wind uplift. Stefanuti and Bresson, having experienced for themselves this first for South Africa, are more than happy to give the lie to the industry joke about a lifetime guarantee for a waterproofing product.